Hello, Matthews Gatos here. In this video, we are going to cover the chain rule. So the chain rule in calculus is used to find the derivative of a composite function. So remember, composite function is something like this, y equals f of g of x. So it's where you have an inside function and an outside function as well. So to do the derivative of f of g of x, we're going to take f prime at g of x and multiply it by g prime at x. So what that really means is that we just take the derivative of the outside, keeping the inside the same, and multiply it by the derivative of the inside. So remember the question that we did with power rule? We had root x plus 3 all squared, and we expanded it, grouped like terms, and then did the derivative using power law. Well, this time I'm going to show you that we can use chain rule to do that because this is a composite function. So to take the derivative, the 2 comes down, keep the inside the same, decrease my power by 1, and then I do the derivative of the inside. So the derivative of root x, that's x to the 1/2. So that's 1/2 x to the negative 1/2. So to finish this off, I'm going to simplify. So half of 2 is 1, and I'm left with the square root of x plus 3 all over root x, which if I want to simplify in another way, I can separate it into 2 fractions with a common denominator, and I would get the same answer that I did last lesson. So I know that that works. So let's use chain rule to do a couple examples here. So in this function here, I have something raised to the exponent of 5. It is a composite function. So to do the derivative, I'm going to bring the 5 down. I will decrease my exponent by 1, and then I'm going to multiply it by the derivative of the inside, which is 6x plus 2. So let's tidy this up a little bit. I've got 5 times. Now I notice I have a common factor of x. So I'm going to take an x, which is raised to the exponent of 4, out, and I'm left with a 3x plus 2 raised to the exponent of 4. Multiply that by GCF of 2, factor that out. And then to simplify this, I'm just going to multiply my monomials together. So I'm going to have 5 times 4 is 10x exponent 4 multiplied by 3x squared, 3x plus 2 to the 4 and 3x plus 1. So that would be my derivative using the chain rule. Let's try another example. In this one here, I have a product multiplied by a binomial. So same thing for power rule. I bring the 2 down and multiply it by the 6 that's already there. Decrease my power by 1, and then I'm going to do the derivative of the inside, which is 7. So to tidy this up, I'm just going to multiply my monomials together. So I'm going to have that my derivative is equal to 84 times 7x minus 5. Okay, let's try another one. Let's try a square root. So again, I always want to write it as a power first if I can. If I can simplify my function in any way, I simplify my derivative. So to take the derivative, I'm going to bring the 1/2 down, multiply it by 1/2 take away 1, which is negative 1/2. Now again, I do have chain rule here. So I have to do the derivative of the inside, which is 6x. So simplifying this, I have half of 6x, which is 3x. So I can write that as 3x all over the root of 3x squared plus 2. Since I started with a root, I end with a root. So that would be my final answer. No need to rationalize the denominator in that question. So we do a lot of roots, and I started to notice a shortcut as I was taking the derivatives. So I wanted to share this shortcut with you. You can use it, or you can fall back on the chain rule, that's fine. But it always works out. The derivative of a square root's always going to be 1 over 2 times the root multiplied by the derivative of the inside. So this is something you can feel free to use. So for example, if I have f of x is the square root of x squared plus x, I know that the derivative is going to be 1 over 2 times that root multiplied by the derivative of the inside. So the derivative of x squared plus x is 2x plus 1. So just tidying this up, I would have that my derivative is 2x plus 1 all over 2 times the root of x squared plus x. So just a shortcut way of simplifying those types of roots. Let's try another one here. So this is a reciprocal function. The first thing I'm going to do is write this as 4x cubed minus 5x plus 2 to the negative 3. So I'm writing it as a power. So to take the derivative, I'm going to bring the negative 3 down, keep the inside the same, decrease my power by 1. Then I'm going to multiply by the derivative of the inside. So the derivative of the inside here is 12x squared minus 5. So tidying this up now, I'm going to have negative 3 times, now I have 12x squared minus 5 in the numerator, and in the denominator I'm going to have 4x cubed minus 5x plus 2 to the positive 4. That will be my derivative. Now, a little shortcut that I want to share with you, I noticed that for reciprocal functions, a pattern started to emerge. So again, this is a little shortcut. If you'd like to use it, you can. If not, you can always fall back on chain rule again. So the derivative of a reciprocal function, now this could be a 1 over, 2 over, negative 3 over, that's what I mean by a reciprocal function, is always going to be the opposite sign of the numerator multiplied by the denominator exponent raised by 1, and of course multiplied by the derivative of the denominator's base, still having that chain rule. So let me show you what that would look like in this derivative. So if I have f of x is negative 6 over, and there's your reciprocal part, 2x plus 5 to the exponent of 7. I'm going to do opposite numerator over denominator increased by 1 multiplied by the derivative of the base. The derivative of 2x plus 5 is just 2. So my derivative is just going to be 12 over 2x plus 5 to the exponent of 8. So if you like that shortcut, feel free to use it. So I just want to end this lesson on chain rule in the words of Mr. T. Mr. T says, "I pity the fool who doesn't understand the chain rule." Well said, Mr. T. So I hope this video helped you. If it did, please give it a thumbs up so I can help more mathies just like you, and I look forward to seeing you for the next video.